Here's a presentation on cellular respiration in a little bit more detail. In this course, we won't need to go into this much detail, but in case anyone is interested on how in depth the cellular respiration process is, I thought I would quickly go over this in a little bit more depth. But again, you don't need to even watch this if you're just looking for what's the basics of the course. Glycolysis is needed for cellular respiration. You remember it takes place in the cytoplasm. The products of glycolysis enter cellular respiration when there's oxygen available. 2 ATP molecules are used to split glucose into it's a 6 carbon atom into 2 3 carbon atoms, and 4 ATP molecules are produced. And 2 molecules of NADH are produced. And 2 molecules of pyruvate, the 3 carbon molecules are produced. So we have glucose, 2 ATPs go to 2 ADPs, so we lose 2 there. We make a 3 carbon molecule, and the second step of this and then is 4 ADPs convert to 4 ATPs as NAD plus goes to NADH and 2 pyruvate molecules, the final product of the 3 carbon chain, which will be taken into the mitochondria. Krebs cycle is the first part of the cellular respiration. Pyruvate is broken down before the Krebs cycle. Carbon dioxide is released. NADH is produced. It's an energy-rich molecule. Coenzyme A bonds to 2 carbon molecules. So pyruvate from glycolysis is broken down. A carbon dioxide is given off. It's a 2 carbon now because the carbon went to carbon dioxide. And acetyl-CoA facilitates bonding 2 of these together to form an intermediate 4 carbon chain that enters the Krebs cycle. Krebs cycle produces energy carrying molecules. It's quite a complex cycle. The citric acid is broken down. NADP plus is converted to NADH. Citric acid is broken down and NADH is made. One of the carbons goes off into a carbon dioxide. 5 carbon chain enters an NAD plus, ATP to NADH to ATP. More carbon dioxide given off. Now our 5 carbon molecules broken down. NADH and ATP is made again. Our 4 carbon molecule then is rearranged. NADH and FADH2 are formed. And finally, ATPs are given off all the way along the way until the process is completed. Krebs cycle produces a lot of energy carrying molecules, NADH, and so on. Excuse me, FAD2, FADH2, these are all highly energetic molecules that are going to use to help with the carbon chain. NADH and FADH2 are made. Intermediate molecules with CoA enters the Krebs cycle. Citric acid, a 6 carbon molecule is formed. Citric acid is broken down. Carbon dioxide is released. Energy-rich NADH is made. 5 carbon molecules broken down. More carbon dioxide is released, and more NADH and ATP are made. And the remaining 4 carbon molecule is rearranged. Electron transport chain is the second part of the cellular respiration. Electron transport chain uses these energy-rich molecules to make ADP, NADH, and FADH2. High energy electrons enter the electron transport chain. Energy is used to transport hydrogen ions across the inner membrane. Hydrogen ions flow through a channel in the membrane. You can see these molecules help push the electrons along and making a bunch of positive hydrogens, which come through the chain, and NADP, adenosine triphosphate, is synthesized. So this is how we get the the ADP to ATP. In the process, water's given off. So we're giving the products of all of this are carbon dioxide from the first part, and now in the electron transport chain we get ATP, the energy of life, going off to help with the chemical reactions with life, and water. Electron transport chain uses NADH and FADH2 to make ATP. So an overview here, the breakdown of one glucose molecule produces up to 38 molecules of ATP. In ATP synthase, anything that ends in an ACE is very likely an enzyme, helps to produce the ATP across that proton channel, as you can see in the picture there. Oxygen picks up electrons and hydrogen atoms and becomes water. And water is released as a waste product, along with oxygen from an earlier part of this.